Before running Hohenly model, let's discuss arrow double securities first. Arrow double securities is very important in finance, especially in finance theory. Okay, it means that arrow double security is a contract that pays $1 for particular situation or contingency, right? Possible arrow double securities is the I pay $1 to you if it rains tomorrow, something like that. So it is state by state contract. State by state contract and pay $1 for a particular state, and we want to know the price of that. Okay. So in the arrow double securities, like interest model, this is our model given by God. There are, in the interest model, there are 6 contingencies, right? 6 months later, now, today is one contingency. Here, 1.74%, that's one contingency. And then 6 months later, there are 2 contingencies. Interest either go up, go down. And then 1 year later, in 1 year, again, interest can go up and down, so there are 3 contingencies. So in total, we have 6 contingencies. And we want to know the price of a contract that pays like $1 over here or $1 over here, something like that. Let's start from the easiest one. Which arrow double securities would be easiest to compute, do you think? So, like, one possible arrow double security is like $1 over here. Suppose a contract pays $1 if interest rate is 5% in 1 year. What is the price of the contract? Something like that. Okay, so that's the value of arrow double security. So again, there are 6 contingencies. So out of the 6 contingencies, we can write 6 arrow double securities. And which one is easiest to compute, do you think? Apparently this one, right? This one is today. If someone promise you to pay $1 right now, what is the value of that contract? 안준혁. If someone promises you to pay $1 right now, what is the value of the contract? Yes. So let's start from easiest one, right? So arrow double securities, in this case, $1. Next, what would be the arrow double security to pay $1 over here? Well, now that's kind of complicated, but now we have like a derivative model. We can maybe use this one. So it is like a $1 over here, $0 over here. So the price is this one, right? So it means arrow double value of arrow double securities that pay $1 at this particular stage is basically $0.64 around there. How about this one? Well, we can also calculate this one easy. Now 1, 0, then you use this one. Right? So value of arrow double security to pay $1 if interest is going down 6 months later is around $0.35, right? Any question until now? No. So one interesting thing is that since we know the arrow double security for all possible, there is only 2 possible scenarios for 6 months later. So it means that we can calculate risk-free asset, right? Definition of risk-free asset is that pays $1 whatever happens, right? And arrow double security is that if interest rate goes up, pay $1, the value of which is $0.64. Interest go down, in the contingency, arrow double security is $35. So it means that if there is a security, risk-free asset that pays $1, what happens is simply sum of these two, right? Right? Because if I have both arrow double securities, then I can receive $1 whatever happens. And the value of this one is sum, right? And then this one is like this one. And actually we already know. So let's check this one. $1, it is exactly 9913. So exactly same. And actually, we already know the value of this zero coupon bond then maturing in 6 months, which is actually this one. Identical, right? Of course, we have to multiply 100, but this one is exactly same to this one, right? So interesting is that if we know value of arrow-developed security, we can again calculate any kind of derivatives. Let's imagine a strange derivative, like debt pay, like $10, debt pay $10, $20 in this scenario, and minus $20 in this. No, that's too easy. Minus $7.5 in this case. We know the value of this derivative, this one. But we can also calculate the derivative of this price of this derivative using arrow-developed securities, right? Using arrow-developed security, we can exactly replicate this one. Well, it is $20, so we can have this arrow-developed security like 20. In order to replicate, we can have arrow-developed security of this one minus 7.5, right? So this is simply sum product. I want to have this one and this one, right? So exactly same. That's why arrow-developed security is so important in the finance theory. If we know the arrow-developed security, we can calculate any kind of derivatives as well. I mean, it is natural, right? Because we know the price of the contract at every possibility. So whatever happens for whatever possibility, we can simply combine arrow-developed securities and we can get the price, right? Is it okay? Well, then, of course, for this one, of course, we can now calculate because now we have 3 ones. So actually, we can calculate arrow-developed security of this one. So for this one, 0, 0, 0, 0. 왜 이러지? 왜 이게 지로가 되면 안 될 것 같은데? 이게 지로가 되면 안 되는. Okay. Obviously, there's something wrong with this formula. So this one is exp minus this one, and then delta multiplied by RP. What is RP? Yes, RP. RP multiplied by this one plus 1 minus RP multiplied by this one. Yes, and then this one is delta RP right, and then yes, this one is P8, right, and then this one is okay. This one is correctly. Let me check it. Same. Okay. So for the arrow-developed securities that pays $1 at this particular stage, now this one should be same to this one. Value. And for the arrow-developed security that pays $1 at the scenario, now we can change this one 0 and 1, and the value is this one. Value only. And then for arrow-developed security pays $1 over here, then we know the value of this one is like this one. And again, we can calculate the price of risk-free asset, which is sum of all arrow-developed securities. It is 9789, which is exactly same to 9789. Okay, it's like this. Okay. So this is LOW securities. Okay. Any question until now? Right? But then actually there is easy way to calculate LOW securities. In the current version, we using these two derivative models, we put one in each cell and calculate LOW security, but that is kind of too uncomfortable, inconvenient. So actually there is a smart way to get the LOW securities. Idea is like this. First, let's start from this one. This one is, of course, this is 1. And this one is, I mean, we know this one is like a risk neutral probability. And then, suppose we receive $1 over here. Is actually this one, $1 over here. And if we receive $1 over here, then value of this LOW security is like probability of this event and discounting, right? Probability of this rate and discounting. So what you can do is, well, in this case, then what you can do is R and P, and then multiplied by, oh, sorry. Sorry, this is the exponential of, we have to discount it, $1. So, yeah, this one. Okay, so discount and then delta multiply R and P, right? So we can use this alternative approach, right? Because I mean, again, if we receive $1 over here, it is like this. It is just 1, so it should be the probability of that occurrence, and we discount it with this rate, right? So it is naturally this one. And in this case, likewise, we can calculate this one as like similarly. Expected. Is there any way? Let me hide this one for the time being. Hide. Not delete it. Hide. Okay. Now it is much better. So okay. In this particular state, what we can do is again this one is right exponential of minus. Okay, this one, because we discounted this rate, multiplied by now delta, discount, this is discount factor, and we know this is 1 minus R and P. Right? So this is same. 0, right? Exactly same, right? So basically, instead of using this tree, we use risk neutral probability and then discounting in backward, so we calculate this one and this one. Like this one is exactly same, right? Now we can apply this logic over here. Here, what we can do is, I mean, we can calculate LOW security over here. So in order to reach LOW security from here to here, we have to have probability going up, right? We have to have probability going up, and then again discount at this rate, right? So what we can do is this one and this one, but now instead of this one, we use RP. RP, right? Right? And likewise, this one is very similar to this one, but yeah. Now discount factor, in order to get $1 value over here, we have to use this discount rate. So yeah, copy and paste, then this discount rate is applied, but now instead of RMP, we have to use RP. Right? Am I right? No. And then $1. So actually, I have to. Okay, so I have to multiply over here, and then this one. Okay, and then I have to multiply this one, and then this one. Why this one is something? 뭐가 이상한데? RP going up, P7. Let me check it. Strange. Oh, okay, right. Okay. So, okay. The logic is this one. Now it is kind of called forward induction. Okay, so forward induction. So now I can copy and paste. No. Okay, and multiplied by 1, and this one multiplied by this one. I have to multiply this one. So now I'm using kind of forward induction. Thing is that in order to get the price of LOW securities and then calculate LOW securities. So again, the initial state, this is $1, this is natural. And for this one is in order to receive $1 over here, from here to move here, we have to move going up and then we have to discount, right? So that's why I multiplied by this $1 initial one, and then going up probability and discounted. Now in order to move from here to here, now we have to move another 1 times up, right? So because we know, so from this particular state, in order to receive this one, we have to move from here to here, so it is going up. So now probably RP, and we have to discount it this rate, right? But now we are thinking everything from the standpoint of this particular one, and the value of LOW security is this $0.64. So now we have to multiply this one, okay, this value and probability of going up and discount. Then we have LOW security for particular this one. Okay. Now, yeah, this one is likewise. We start from this one. As we start from here and move this one, similarly, we think everything in terms of this point. And from this point, in order to receive $1, we have to first go down. So probability is 1 minus RP and discount it at this particular rate. But now, since the price of LOW security is this value, now we have to multiply this entire thing and LOW security price at this particular price, particular space, particular point, then the LOW security price like this one. Okay? Yeah, I know it is kind of confusing, but I mean, it shouldn't be that confusing though. I mean, is it clear now? So let me ask one question. So now, in order to calculate LOW security for this blank area, okay, how do you think we can calculate LOW securities? Now we cannot do this one anymore because in order to reach this point, there are 2 paths. We can go from here to here or going from here to here. So the method is slightly, we have to modify slightly the method. So how do you think you can calculate LOW security over here using this forward induction process? Any idea? Okay, let's think about it. Now, in order to receive $1 over here, there we have to think from this particular state and this state, right? Because it can go down and going up. So in order to reach this particular state, there are 2 paths. So it means that we have to add price of these 2 LOW securities that move from here to here and here to here, right? Isn't it natural? So first pass from here to here, then it is same. As we calculate this one, we can calculate the value of LOW security from moving from here to here. That is, of course, what we can do is first we have to discount it with this rate. Okay, we discount with this rate, and then multiplied by delta, and then now from here to here, now probability is going down, so it is 1 minus RP, right? So this is the price of LOW security over here at this point from the perspective of this one. But in order to reach this one, or value price of this particular state is this one, so now I have to multiply this one, okay? So this is one path from moving over here. But this is not enough. We have another path. We have to move from here to here again. Then what we can do is we have to add, right? We have to add now such that we have to calculate LOW security from this particular point, and this particular point, discount rate is this one. Okay, and multiplied by delta. And then now, from this particular stage, now we have to move up. So now we have to move multiply plus RP. And then this is price of, so up to this part is price of LOW security from the perspective of this one. But now the price of this state is 0.35. Now we have to multiply this one as well, right? So this is the price of LOW security at a particular state. Actually, we can copy and paste this one as well. Same, because it's empty. Because this series is empty and this is empty. So now it is fine. Okay? So using this fourth process, we can do, I mean, yeah. So any questions? So actually, I can copy and paste over here as well. But I have to use R and P because the risk neutral property now different. And then R and P. Yes. So this is very important. That's how. So in this LOW security, now we don't have to use these things. We don't have to use this thing, okay, this anymore. What we can calculate the LOW securities from this particular point, and then what you can do is we can calculate from this particular point, and if we know interest rate and risk neutral probability, then we can calculate all LOW securities. If once we get all LOW securities, then we can calculate all derivative prices. Any derivative, even path dependent prices. I mean, if we use this one, then we can calculate everything from the point of a terminal price, right? But now there are possibly some very weird. Let's think about very weird. Let me think of weird derivative. So this is something I'm interested. And we can imagine some very weird derivative such that pays $10 over here, $5 here, minus $8 over here. And if we reach this one like $6 and then minus $5. And maybe we are interested in the derivative that pays this one. So it is very path, this is called path dependent derivative because it is dependent on path. If we follow this path going up, then we receive $16 in growth. If this one move like this one, we receive nothing because I have to pay minus $5 and pay $5. If it moves like this one, I receive $11. If I move this, then minus $13. Sometimes this, so it is very, very, very complicated path-dependent contracts. But still, it is not so difficult. We can calculate the price of this path-dependent contract by some product. Okay, this one and this one. This one plus some product, and then this one, and then this one. Done. So we can calculate this very weird, strange derivative as well, right? So this is the power of LOW security. We can even calculate path-dependent derivatives. Okay? This is very important one. Very, very important in finance. Any question? So please remember, just this cell is the most important part. Okay, most important part. Let me highlight this one. Is this color the most important part? Because I mean, yeah. So again, in order to calculate LOW security situation, we need for the induction process because we recover this LOW security from this one and this one. From this one, we calculate LOW security from the perspective of this point, and then multiply price of this one. Plus, we calculate LOW security from this perspective and multiply the price of itself, and then sum them all, then it is LOW security of this one. So it is for the induction. just where is 1?
Like the 0.639 something.
0.6. Yeah, this one.
Yeah, like you multiply by RMP, but after the next node, and the next one.
You mean this one?
No,
You mean this one?
the highlighted one on the right. Cell C38.
So actually, so this cell is empty. You can ignore this part. Basically, this part is just because it is empty. You can ignore this part because this part is anyway 0, right? A38 is 0, so this part is 0. So all important part is just this part. It's just $1. $1. From this perspective, from this particular point, I calculate error-degree securities, which is I have to move up, so probability going up, R and P, and then because in the future I have to discount it. But now the price of this particular state is $1, which is A39, is $1. So this one.
Yeah, I understand this, but like, why in the next one and the one where there's 3 error-degree security, you multiply by RP instead of RMP?
Oh, you missed the previous class. You are asking that question because you missed very important previous class. The R and P, so okay. Yes. So unhide, okay. Unhide. So we have 2 risk neutral probability because first risk neutral probability going up from here and second risk neutral probability going up from this one. Okay, so right now the probable risk neutral RMP of going up is like 64%. But 6 months later, we have no guarantee that 6 months later risk neutral probability is the same. And indeed, 6 months later, RNP is like 78%. So because we are talking about in future over here, so it is RNP. So from here, I calculate risk neutral. I'm calculating error-degree security at this particular point, and moving from here to here, I have to use RNP. And from this point, now it is a future, so I have to use RNP of the 1 6 months later, which is RP over here. No, this is RP over here. So this is RP. So this I have to use RMP for this line because it's 6 months later, and I have the RP 6 months. So it is from 6 months to 1 year risk neutral probability, and for this one, I'm using risk neutral from today to 6 months. Yeah, so you missed the previous class, and that was an important one. Well, I'm sorry, but yeah. Any other? Huh? Where is the 2-step? Oh yes, it is the name of this particular sheet. Yeah, the 2-step. Yeah, in Excel it is. Yeah. I mean, somehow I just write down RMP and it automatically changes the 2-step. So basically now I'm pretty sure that you learned everything you want to know. Yeah. You can calculate every derivatives, even path dependent one, even crazy derivatives. So this is all. Yeah. This is basically entire, I mean, I'm pretty sure you learned everything you need to know in this class basically. Any other question? No? 질문 있어요? 한국말로 해도 돼요? 예. 사실 크레이지가 아니지. 뭐 어쨌든. 네. 어디 어느 거? 예? 그건 내가 아무렇게나 쓴 거예요 지금. 어떤 거? 크레지 데리버티브 아니면 타겟 데리버티브? 그러니까 타겟 데리버티브는 뭐냐면 그러니까 이게 가상적인 어떤 상황에서 얼마를 받을지를 보여주는 맵이야 이 뒷부분은. 네, 그러니까 일단 이쪽으로 이자율이 올라가면 일단 $6를 받는 거야. $6가 생기는 거지. 그러지. 그 다음에 또 가면 $10를 또 받아. 이렇게 가면 $5를 받고 이렇게 가면 $8를 내야 돼. 뭐 이런 거지. 그러니까 이거와 이걸 결합해야 되니까 그냥 하면 상당히 귀찮겠죠. 네. 네. 그러니까 60 만약 이런 걸 계산하려면 그러니까 이런 식으로 해야지. 그렇죠? 0, 0, 0, 60 이런 걸 계산하려면 만약 우리가 에로우드브루 시큐리티가 없으면 이걸로 먼저 6달러를 받는 걸 계산하고 그렇지. 네. 그 다음에 또 여기서 10달러를 받는 걸 계산해서 이 두 개를 합쳐야 이게 되겠죠. 네, 이론적으로 보면. 네. 그렇잖아. 여기서 6달러 받고 여기서 10달러 받는 거니까 이 두 개를 두 개의 데리바티브에서 분리하면 올라갔을 때 일단 6달러 받는 이 데리바티브하고 또 한 번 올라가 10달러 받는 이 데리바티브 합쳐야 되는 거 이거 썸이 되겠지. 그냥 너무 귀찮잖아. 근데 이게 한 번에 할 수 있다 이거지. 에로우드브루 시큐리티를 이용하면. 네? 그러니까 10 마이너스 10 마이너스 5 뭐 마이너스 5 3 4 2 이렇게 주는 것도 위 두 개를 이용해서 구할 수가 있어요. 이게 무슨 말이냐면 그러면 여기서 마이너스 5고 여기서 4고 그 다음에 여기서 6이고 여기서 2고 그리고 이 두 개의 데리바티브로 분리할 수가 있으니까 이걸 합히면 그리고 이거 더하기 이게 돼서 뭐 똑같은 숫자가 나오지. 네, 무슨 말인지 알겠어 이제? 네. 또 질문? 네, 좋은 질문이었어요. 네. 아니 지금 이게 실제로 이렇게 쓰면 되지. 아 사이트에 들어가서 아니 이런 걸 누가 나나 이렇게 공짜로 이렇게 친절하게 이렇게 누가 인터넷에서 이런 걸 친절하게 알려줘. 그런 사람은 없어요 이 세상에. 뭐 코세라에 가서 찾아보면 비슷한 강의가 있겠지. 네, 그렇지 않고 어디 인터넷 한번 공부해 볼까? 어디 보자. 에로우드브루 시큐리티스 바이노미얼 트리 implied binomial model 뭐가 있긴 있네. construct integrated binomial tree for 호헨리 모델을 이용해서 한 게 또 있네요. 나도 설명하려고 그랬는데. 오케이 한번 볼까? 에로우드브루 시큐리티 호헨리 에로우드브루 페이업 여기 있네. 예. CI가 에로우드브루 프라이스 and they are known 뭐 이렇게 하면 된다. 뭐 있는 것 같아요. 예. 에로우드브루 프라이스는 여기서 이렇게 P 하고 뭐 하는데 뭐 그렇게 친절하게 안 설명이 돼 있네. 나처럼. 예. 아 무슨 여기 있네 여기 이렇게 가서 이렇게 해서 뭐 이렇게 구한다. 이렇게 설명이 있긴 있네요. 예. 읽어보면 무슨 말인지 잘 모를 거야. 예. 자 또. 네. 아니야, 그건 내가 지난 시간 내내 설명한 거 아니야, 그게. 아무 설명해 물어봐도 되는데 내가 지난 시간 내내 설명한 게 예, RP하고 RMP인데. 자, 다시 한번. 오케이, let me explain one by one. 오케이, so R and P is 지난 시간 내가 목이 터져라 그거 설명했는데. 오케이, R and P is probability going up from here to here. 1 minus R and P is here to here. Now RP is moving from here to here. or here to here. 1 minus RP from here to here or here to here. 그건 내가 인셉션 설명하면서 내가 지지난 시간에 또 목이 터져라 설명한 거 아니야. 한 줄 더 생기면 내가 숙제로 내줄 거야. 걱정하지 마. 한 줄이 아니라 아니 그건 어차피 R로 할 거니까 RP1, RP2 이렇게 해서 여러분이 이름 짓기 나름이고. 걱정 마. 내가 그러니까 여러분 그러니까 뭐냐면 숙제는 내가 다음에 내줄 숙제는 뭐냐면 이거겠지. 일드 데이터만 한 20개를 줘. 20개를. 20개를 주고 그 다음에 에로우드브루 시큐리티를 구하시오. 그러니까 이걸 20개 주면 리스크 뉴트럴 프로바빌리티도 19개가 나오겠지. 19개가 나오고 그 다음에 에로우드브루 시큐리티고 이런 숙제를 내주겠지. 그러면 절대 엑셀을 못하고 코딩을 할 수밖에 없겠지. 자 또 그런 숙제를 조만간 내줄 거니까 걱정하지 마요. 자, 뭘 질문했지? 왜 리스크 뉴트럴 프로바빌리티라고 부르냐? So this is called risk neutral probability because 내가 목이 터져라 설명했는데 그때 질문을 하지 왜 지금 하는 거야? 어쨌든 네. So okay, this one, right? something Q P T. Okay, do you remember this equation? This is the fundamental equation in asset pricing. One of the most, this looks simple and obvious, but this is the fundamental, one of the most important equation in finance. Okay, and Black and Scholes, no, Black dead. So Scholes and Merton got Nobel Prize because of this one. Okay, this is risk neutral probability because when we are interested in the price of some asset, what we do is we assume that we are in the risk neutral world and calculate the asset expected value of this particular asset at this particular risk neutral world, and we discount it with risk-free rate. Okay? And then this theory tells us that this is the real price, although we calculate the asset price in the imaginary risk neutral world. Okay, so the thing is that actually if we know the price of some asset at today, what we can do is from this value, we calculate this one. We calculate basically this operator, okay, or risk neutral probability from this one. And once we collect risk neutral probability, then what we can do is for any asset, we calculate expected value of that one, and then discount it. And now we get value of this particular asset. So in our example, we use yield curve, or we use bond prices, zero coupon bond price, in order to calculate risk neutral probabilities. And once we calculate risk neutral probabilities, we can simply calculate the value of any crazy derivative using that risk neutral probabilities and get the expectation and discount, and we get the price. And that's why we call it risk neutral pricing or risk neutral probability. And this is, and you shouldn't be confused that this risk neutral probability is not real probability. Okay? Although we get risk neutral probability in this case, which is 64% and 6 months later is 79%. It does not mean that actually interest is going up today with probability 64%. Does not say that. It is possible probability of going up only in the particular risk neutral world, not the real world. Okay. Actually, some people always consider that this is risk neutral probability go up, and some people think that there is actual probability going on. No, this is not. Okay. Actual probability of interest going up is too hard to calculate. It depends on all macroeconomic variables or mind of Bank of Korea, President of Bank of Korea, or complicated thing. It is maybe too difficult. But this risk neutral probability is very easy. We can calculate from the yield curve. Yield curve is enough. Okay. Again, the process is like this. This is data, right? This is data. This is only given data. From this data and hypothetical risk interest-free interest rate model, using this one and this one, we calculate risk neutral probability. Once we get the risk neutral probability, we can get error-able securities or whatever derivative we want done. 네? 질문 있었나? 답변이 됐나? 네, 안 된 것 같아. 그러니까 내가 다시 설명해 줄 수가 없어. 네? 지난 2주일 동안 내가 열심히 설명한 걸 다시 설명하면 또 2주일이 걸리거든. 어떻게 다시 할까? 잘 복습해 보세요. 그건 인터넷 검색하면 나올 거야. Risk Neutral Valuation, Risk Neutral Price, Asset Pricing 뭐 이렇게 구글 검색하면 좀 자료가 있을 거고, 그 다음에 교과서 있잖아. 그렇지, 교과서 보면 되겠네. 물론 교과서는 상당히 어려울 거야. 근데 내가 한번 설명을 해주고 읽으면 이제 이해할 수 있을 거예요. 교과서가 충분히 이해할 수 있을 거예요. 책 샀지? 빌렸어? 웬만하면 사지. 이거 좋은 책인데. 아무튼 책을 읽어봐요. 챕터 9, 챕터 9을 읽어보면 될 거야. So if you want more information about this risk neutral valuation, please read chapter 9 of the textbook. Okay.
여기 가능하면서 그렇고요. RP가 두 개를 돌려서 솔브하고 세 개 돌려서 솔브하는 게 아니에요?
자, 뭐냐면 이게 스텝 바이 스텝이야. 먼저 R and P를 so when we using solver, okay, solver, we calculate this one first. Okay, we calculate this one first using solver, and we use this one and second one for second So using this one, okay, so this data, we have bond price merchant one. So this tree, then in order to match pricing error of this one, we can calculate, okay, to make this one, we can calculate risk neutral probability. And for this risk neutral probability, now we match 1.5 year bond, and then pricing 0, so this one. But from here to here, we use risk neutral probability, this one, and from here to here, we do risk neutral probability, this one. So basically, using this one, we match this one. So this one is known, but now for using this tree, we calculate this one. And then using this one, we can calculate everything else. So any other question? 이것만 알고 여러분 취직해도 진짜 딱 이것만 알고 취직해도 진짜 있어 보일 텐데. 어디 어떤 금융기관에 가도 모든 데리바티브 프라이싱 할 수 있으니까 정말 이것만 알고 가도 여러분은 파생상품에 대한 엄청난 지식을 사실 가지고 있는 거예요, 사실. 게다가 R로, 그래서 리스크 뉴트럴 밸류에이션 이해하고 그걸 R로 임플리멘테이션 할 수 있으면 여러분은 진짜 당장 미래에셋이나 삼성증권 같은 데 주식에서 퀀트로 일할 수 있어, 솔직히. 이것만 알아도. 거기 가서 데이터 받아서 여러분은 이자율 파생상품 이런 거 다 구할 수 있어, 진짜 이것만 가지고요. 그렇지, 못 구할 게 없지. 예. 게다가 내가 앞으로 내줄 숙제 하나 한 20개짜리 일드컵으로 해서 20개의 리스크 뉴트럴 프로버티 구하고 20단계 에로드브로 세큐리티 구하는 거 한 번 하면 여러분 인더스트리에 가서 진짜 이자율 퀀트 할 수 있어요. 픽스드 인컴 본드 퀀트 할 수 있어요. 네. 주식 퀀트는 더 쉬워 이거보다. 그러니까 그것도 할 수 있어. 네, 그러니까 여러분이 꼭 이걸 이해했으면 좋겠네. Anyway, my original plan is to study Ho-and-Lee model today, but obviously I don't have time to go over Ho-and-Lee model today, so I'll study Ho-and-Lee model next Wednesday. And because today is Labor Day, and it seems that some students are missing today, so I think it is enough for today. Any question? Okay, thank you and see you next Wednesday.